Hello friends, my name is Mohsin Mullah and I once again welcome you all back to the video lecture series on electrical drives for industrial automation and control. So this is the you can say final lecture on the stepper motor drive. So previously in previous videos we have already seen the types of stepper motors and the constructional details of the permanent magnet stepper motor as well as the variable reluctance type stepper motor, and also we have seen how the switching operation is used in order to achieve the rotation that we are expecting the motor to rotate by whatever angle we want to rotate it, by whatever step, either full step or half step rotation, that can also be obtained with the help of switching operation. So that also we have covered so far, and in this video lecture specifically I would like to concentrate on the control scheme of the stepper motor. So in many cases stepper motors are used for positioning of tools and devices. So precision control over the rotation of step motor is required for these cases. So therefore, in order to obtain the precision control of the rotation of the step motor, so there are two ways in which it can be obtained. That is, one is open loop control as well as the closed loop control mechanism. So the closed loop control is a much simpler and most widely used mechanism. So simply here a command is given to the pulse generator that sets the number of steps and also the direction of the rotation of step motor. Then the pulse generator is going to generate a train of pulse. Okay, so that will be given to the translator. So that translator is a simple logical device which distributes this pulse train to various transistors, okay, that are connected in the stator winding. So that will act as switches. So now amplifier is a device that will amplify the signal, and it gives the driving current to the stator winding of the step motor here. Then finally the step motor is going to rotate according to the number of steps decided by the command. But here the major disadvantage of this type of scheme is that, so here if any pulse is missed, so it cannot be detected and there is no way to correct the switching sequence. So because of which, so the rotor might behave erratically. Okay, so we need to overcome that disadvantage. So also here directional pulse train is given to the step motor for selecting the direction. So when the pulse train is given, that direction pulse train is given to the translator, in that case the step motor reverses its direction of rotation. So now to overcome the disadvantage of the step motor, that if any pulse is missed it cannot be detected, then we need to have a feedback mechanism to detect the whether we have got the number of steps as per set steps by the command signal or not. So it requires a feedback mechanism. So here is a schematic representation of a closed loop or feedback control of a step motor. So here what happens is, so here the feedback mechanism detects the number of pulses, or you can say number of steps from the response side, and it here an incremental encoder is used. So here incremental encoder is simply a digital transducer that measures the angular displacement of the rotor. In case it rotates by a certain angle, so there will be an incremented by 1. So likewise we will come to know whether as many steps have been rotated by the motor as decided by the command signal. So if the previous you can say pulses whatever were supplied, according to that the steps have been rotated obtained by the step motor, only in that case the next pulse train will be given to the driving circuit, until and unless it is made sure that the motor has rotated in the proper direction and for the proper number of set steps as sent by the previous pulse train. So here it does not allow for the further you can say further sending of the control pulse train to the driving system. So in that way it is possible to have a proper control over the rotation of the step motor, and it is also you can say very easy to determine whether the number of pulses applied are directly being transferred to the step motor or not. So this way we can achieve the precise control of step motor. Okay, so now we have come to the end of this particular stepper motor drive. Okay, So now stepper motor is actually it is used mostly as an actuator. Okay, therefore it is essential to have more precise control of the stepper motor. So therefore any of these two type of control strategies can be used as per the can say requirement of that particular application. And also here the step motors are nowadays widely used because the control strategies are available, and because of their nature they are very readily interfaced with the computer for the control of rotation. And also nowadays the step motors are able to produce larger torques. Therefore nowadays you can say most of the applications in most of the applications step motors are replacing the conventional AC and DC motors. So therefore that's it in this particular video lecture here. And in the coming video lectures of the electrical drives I am going to cover about the DC drives, or you can say servo control, servo motor control drives, etc. So till then, happy learning and thank you.